We're going to talk briefly today about the transformations of logarithmic functions. Now, very fortunately, all transformations applied to log functions are the exact same as previous functions that you've seen, and so we can rely on that prior knowledge a lot easier in order to figure this out. The first variable that I have here in our equation is a. And a, just like with previous functions, represents your vertical stretch. If a is greater than 1, right? Or a compression if it is between 0 and 1. And then, of course, if it is negative, then you have a vertical reflection. Which is across the x-axis. Our second variable at play here is the k value, which is inside the logarithmic function. And you recall that anything inside works the opposite way. So here we're talking about a horizontal stretch. But that's only if it's between 0 and 1, right? If it's some kind of decimal like half, then it's a stretch. Otherwise, it's a compression if it's greater than 1. Okay? And this is done by a factor of what we call 1 over k. Okay, by the opposite of that. And then, of course, if it is negative, then we have a horizontal reflection, which is across our y-axis. Then we have our d value. Remember, d is also going to be doing the opposite thing because it is inside our function. The d value represents a horizontal shift. If it is like x minus d, then you're moving to the right. And if it's nx plus d, then you're moving to the left. It really depends on the sign there. The other thing that d tells us is the location of our vertical asymptote. Our vertical asymptote is located at the point x is equal to d. That's a big one. That's important to remember. All right, and then our last transformation that is applied is, of course, the h value. And just like with other functions, the h value represents a vertical shift. So if h is greater than 0, you're going up. And if h is less than 0, you're going down. Okay? We'll do 2 quick examples. List the transformations applied to the function f of x is equal to 1 over 3 log negative 2 bracket x plus 3 and the whole thing plus 3. We'll just go in order. I have a vertical compression. By 1 over 3. As seen in the 1 over 3 that's out front there. My next number in line is the negative 2, which actually tells me 2 things. First things first, I can see that there is a horizontal compression by 1 over 2. Remember, it's always 1 over the k value. And then I also have a flip here, or I have a reflection over the y-axis. It's a horizontal reflection. Next in line is the 3. This is our d value. It is our horizontal shift. We have a horizontal shift of 3, and in this case it's to the left. Because the 3 in the bracket there's positive, and you always go in the opposite direction. And then last but not least, we have the plus 3 at the end here. And that plus 3 is a vertical shift. Up by 3. The question has also asked me to state the equation of the vertical asymptote. Recall that the vertical asymptote is located at x is equal to d, and my d value is 3. So I'm going to say my vertical asymptote is at x is equal to -3, opposite sign of the one that's in the bracket. Okay, let's do a second example here. Write the equation of the log function with the following transformations. It's been flipped over the y-axis, shifted left by 4, stretched vertically by a factor of 5, shifted down by 10, and then compressed horizontally by a factor of 1/3. Okay, let's dig these apart. First off, if it's being flipped over the y-axis, this is a horizontal flip, and this is telling me that my k value is negative. I don't know what it is yet, but I know that it's negative. If it's shifted to the left by 4, that means my d value is -4, or it's going to look like x plus 4. This is being stretched vertically by a factor of 5, so my a value is 5. And it's being shifted down by 10, so my h value is -10. It's going down. And then lastly, it is being compressed horizontally by a factor of 1/3. So my k value is going to be 3. It's the inverse, recall. So let's put this all down here into our function. F of x is equal to, and I'm just going to leave a blank, log of something, bracket x, and then I'll end up closing these brackets, and then I put the rest in. Okay, I'm just going to go in order here. We know k is negative, so I'm going to put a negative sign here. D is -4, so my bracket reads plus 4. A is 5, so I add a 5 out front. H is -10, so my tail will be -10. And then my k value is 3. I put a 3 right there. If we were also asked to determine the location of our vertical asymptote in this case is located at x is equal to -4. Remember, it's the opposite sign of whatever the d value is. Okay, and that's it. Transformations are pretty straightforward.